Hey everyone, welcome back to another video. In today's video, I am going to solve sum tree. And in this video, first we explain the problem statement and then we explain the implementation with examples. Then we understand the approach using flowchart, and at last we write down the code and with complexity. Okay, what is the complexity of this problem statement? So before starting today's video, please like and share, and if you are new, please subscribe. Go to problem statement. In problem statement, you have given a binary tree and check for sum tree for every node, expect the leaf node and return true if it is sum tree, otherwise return false. Okay. Now question is, what is sum tree? Sum tree basically is a binary tree where the value of a node is equal to the sum of the nodes present in left side subtree and right subtree. Okay, and an empty tree is also a sum tree, and as the sum of an empty tree, then it will be considered to be zero. Sum will be considered zero in empty tree. Okay, empty sum tree. And a leaf node is also considered a sum tree. Okay, now understand. Basically, what we have to find? We have to find sum of tree. This is a binary tree. Like this is a binary tree. Okay, and in this binary, we have to find sum of tree. How can we calculate? We calculate using left subtree and right subtree node value. Okay, and if left subtree and right subtree node value sum is root value equal to root value, then in that case it will be a sum tree that called sum tree, and we have to find this thing. Okay, hope understand. Now in first example, given this binary tree and this is root node, this is root node. Okay, and this is left node or left subtree. There is only one node in left side, so it is a left node. Okay, and it is right node. Okay, now calculate the sum of this left node and right node value. Okay, left node value is 1 and right node value is 2. 1 plus 2 equals to 3. Now what is our root node value? Root node value is 3. So we have to find if root node value root node value and sum of these left and right node value is equal to root node, then that called sum tree. So in this case you can see left node and right node value is equal to our root node. So in this case, in output it will show true, because we find some tree, we said it satisfy our condition. Okay, in output it will true. Now in second example, given root node is 10. Root node is 10. Okay, fine. And this is left subtree. This called left subtree, and this is right. Okay, this is right and this is left subtree. Okay, now calculate sum of left subtree and right subtree value. Now left subtree value is left subtree value. Calculate what is first 20, 20, then 10, 10. Okay, 10 plus 10, 10 plus 10. Now calculate this sum of this will be 20 plus 10, 30, 30 plus 10, 40. Okay, 40. Left subtree value is 40. Okay, now calculate right side value. Only there is only one node, so it value is 30. Now left subtree. Now left subtree and right subtree sum. Right subtree plus left subtree value. Right subtree sum is 30, so 30 plus what is left subtree value? Left subtree sum value is 40, so it will be 40. Now 30 plus 40 is 70. Now sum is 70. Is it equal to our root value? Is it equal to our root value? No, it is not equal to our root value, so we don't satisfy our condition. So in this case output will be false. That's it, it will be false. Okay, now what is the approach of this? How can we solve this? Okay, basically what we do, first I have write down a flow chart for your better understand. First, we calculate. We start our operation. Then we check if is node is null. Is node is none. Then if it is, then it will return true. If it is, then it will return true. If it no, then it will return nothing. Okay. And next condition is node a leaf node? Is node a leaf node? If it is yes, then it will return true and it will return that node data. Okay. And if it no, then it will return nothing. And after that, we recursively traverse left and right children of the binary tree. We recursively traverse the left and right children. Then we check. Then we check is node data equals to left sum and right sum. Means if root node value is equal to left sum value plus right sum value, if it is equals to root left sum and right sum value, so we check if it is yes, then if it is, then it will be return true and return left sum value and right sum value and with the node data means root value. Okay. And if it's node, then it will return false. Okay. Then at the last stage it will return our final result. Okay. And it will end our operation. That's it. Very simple. Now what is the time complexity of this? Time complexity will be O of n. Here n is the number of nodes. N is the number of nodes and space complexity will be O of h. H is the height of the binary tree. Okay, H is the height of the binary tree. Now go to code. Code is some long, so I write down the code here. Time this time. Okay, first we define is tree a helper function to check is a binary tree. Okay, and tree is empty or not. If tree is empty, then it will return true, because in given problem statement there, if tree is empty, then it will also is some tree. Okay, and result will be zero in that case if empty tree. Okay, and then we check if leaf node is a sum tree. So we create a if condition, and then we recursively check the right and left subtree. We recursively traverse the right and left subtree. Then we check the current node of some tree. Then we return the result with current node. Okay, current node. And after that, what we'll do? We define is sum tree equals to sum tree. Help using helper function, we call that, and then we create a new tree node. Create a new tree node, and then we create a function to build the tree, and then we just simply split the node and recursively traverse the whole tree. Okay, and at the last line we return the root node value. Okay, that's it. Now compile and run, and now submit. Okay, we solved today's problem. Hope so today's video is helpful to you. See you next video. Still and bye bye.